Hello everyone, and welcome to the third clip of the C# for Beginners series, where we'll discuss the process of storing information in order to make our programs remember things. This is achieved with something called variables, just like we used to do in mathematics with x and y. If you wanted to store the value 5, you'd say something like x equals 5. And in that case, x is a variable because it holds a value, but also because that value can change. At any time you can say x equals 10. And because of that, because its value can change, we say x has a variable value, or shorter, that x is a variable. Now, let's imagine the computer scenario. Let's say you have a program for printing a document, and every time you run this program, it will display a message for asking you the file name and the number of copies you want to print. When you input that information, the program stores the data you entered at some memory location. To help the program find the memory location where this data was stored, every memory location has a unique address. And because there can be billions of such addresses, keeping track of every memory location can become very difficult. And because of that, we have variables, which are names that the program associates with some locations in memory. As I already said, the values stored at those memory locations can be modified during the program's execution. A variable is defined by two things: its name and its type, which tells the computer how much memory it needs to store that particular type of data, and what operations the program can perform on it. In our previous example, the program that prints a document would have a variable called file name, which will store the name of the file you want to print, and another variable called number of copies, which obviously will store the number of copies you want to print. In our code, we would reference those variables by their names and not by their memory locations, and because of that, you should always choose significant names for your variables, unlike math, where they are always called x and y. C# accepts the following base types, also known as primitive types, with the exception of string, which is a derived type, for numeric values of natural numbers, which are numbers that don't have a fractional part. We have int and byte. For numbers that do require a fractional part, also known as real numbers, we have float, double, and decimal. When it comes to text, we have char for a single letter and string for regular text. And finally, for truth values, like today is Monday, which can only be true or false, we have Boolean values. So let's try and use one of each of these variables. In order to make the program know about a variable, we need to declare it, which means creating a variable by telling the compiler its type and its name, like this. But this only means that now the program knows about a variable called age, which is of type int, which means it can store integer numbers. But we haven't given it a value yet. So this is where initialization comes in, which is the process of assigning an initial value to a variable by using the assignment operator, or as you know it, the equal sign. We can even combine declaration and initialization in a single step. And we can even declare and initialize multiple variables on a single line, although this is not really widely used. Next variable, byte, is kinda like int, but for specialized situations that you as a beginner don't really need. The next kind of variables are for not so precise real numbers, like for instance, if you are building a game and you want to store the trajectory of a rocket, you wouldn't need to store that down to an inch level. You don't need that kind of accuracy, or you'd just waste processing power. And for those situations, we have float, which is the smallest real type variable, where the fractional part precision is not that crucial, but it's still good enough for most situations. And notice that I had to put that f at the end so that the compiler understands that I'm assigning a float variable. If I didn't, it would be considered by default a different kind of value, which is a double, which is the next kind of real number variable that we are going to discuss about. Double is precisely the same as float, it only occupies twice as much memory, so hence the name. But because it's exactly the same as float, it's also not 100% accurate. It's a lot more accurate, but still not 100%. For places where precision is a mandatory requirement, and you absolutely never have to have any rounding errors like banking, commerce, nuclear reactors, you name it, we have decimal, which requires 4 times more memory than a float, but it's also designed in a way to always accurately express fractional numbers, like this. Notice that I also have to put again an M after the value, otherwise it will be treated as a double. Next, let's deal with text. We have char, which is a single letter, and you declare and initialize it like this. But usually you don't declare variables of type char. It's rather used in string manipulations, like for instance when you have to do something character by character. Mostly you will use string for text. And notice the difference between char and string. Not only one can store a single character and the other more than that, but one uses single quotes to encapsulate its value and the other uses double quotes. Finally, we have the bool variable type, which you declare and initialize like so. There are many other variable types and variations of them out there, but the vast majority you will ever use are these right here, and again not even these all the time. In the next lesson we'll learn how to make our programs interact with the outside world, with us, to either display data or to ask data from us, which is pretty cool. If at some point in the future I'll create an advanced version of this video and you are interested in a deeper understanding of software engineering, check out the link video in the description as well. If you enjoyed this video and you learned something from it, help me by subscribing to the channel and pressing the like button. If not, that's okay too, but you should still subscribe. Just kidding. Thanks for watching and I'll see you in the next tech frame.